And the review is not important. And the review is not. And the review is not too important. Recording.
Professor, I do have a question. So, like, you multiply the 5 by 3.14?
Divided by 6, yes.
Okay, thank you.
Now, 3, 4, and 5 is super easy as conversion degree to radian. And this is my super fantastic formula. Theta in radians is equal theta in degree multiplication by pi and divided by 180. Let's do it 1 by 1. 3. That's 36 degree. So 36 times pi divided by 180. Okay, so now you take 36 and 180 and you reduce in lowest term is pi over 5. And leave it like that, like a function of pi. Yeah, because you divide by 36, 36 divided by 36 is 1, and 36 divided 180 divided by 36 is 5. Do you follow me?
Yes.
Okay. The next is negative 90. Well, negative 90 is negative 90 multiplication by pi divided by 180 is negative pi over 2.
So, Professor, sorry, we are just simplify like the 36.
Yeah. Depending, no. You know, so you replace this by 3.14, it's okay, but give me a weird decimal. Entonces, normally we want the angle and radian as a function of pi. It's the most common way. Number 5 is similar. It's 6 degree. 6 multiplication by pi divided by 180. When you simplification is 30. So it's pi over 30. Pi over 30 is boom. Any question? Good. May I erase?
We need to simplify.
Yeah. Nuela, in the majority of calculator, I don't know exactly what calculator you have. We have one key against ABC. And you put, for example, 6, you press this key, give me that symbol, 180. When you press equal, automatically reduce the lowest term, like a 1 over 30. Either way. Calculator by hand, either way.
Okay, I think I'll do by hand. I don't have this key, Professor.
No, it's okay. Now, in the question 6 and 7 is a sector. Sector, what is a sector? I forgot to explain in the lecture this, but this is easy. It's similar. Look, sector is the area. This is the piece of pie, and the area inside is area of the sector, area, capital A. And the formula is area of the sector is equal 1/2 radius square theta. And theta, again, similar to the R length, is expressed in radian. So a number 6 problem, radius given is 20 inches. Theta is pi over 6. Okay, it's already expressed in radian. Nice. I appreciate so much this. So the area is equal 1/2 times 20 squared, okay, 400, multiplication by pi over 6. Entonces 400 divided by 2 is 200, divided by 6, and replace pi by 3.15, because the answer I want, I am doing in decimal. Entonces is 104.72. 104.72. This is, I don't know exactly. And in the calculator, I get the answer. However, what the most answer gets close to this is 104. Can be. Okay, it's area. Remember, we have two quantity in this. Our length is that distance. Area of the sector is the surface que I highlight in green color. Es obvio que the unit of this is inches square. Because it's the same unit of the radio que es inch per square. Because of surface. This is question number 6. And the question number 7 is similar.
Professor, sorry, and like the case, it says like 104.67. You put 72.
Yeah. This is the answer I get in my calculator.
But I got the same answer as it is on the paper, actually, because I put on my calculator too.
Okay. Because I make it maybe. Okay. Then number 7, the radius 4 feet. And the angle is no given. The angle is the thing I need to find. And the area of the sector is given, is 47 feet. We're using the same formula, this formula. But the unknown is theta. So 47 is equal 1/2 radius 4 square theta. So you isolate, you isolate this. This is 16 is 8 divided by 8 both sides is theta is 5.875 radians in decimal. 5.8 something B in decimal. Okay, entonces I suppose que in the test you see one question about the R length S and one question of the area of the sector, que is capital A. So far it's okay?
Yes.
Okay, super. Guys, I am doing fast because it's a review, no? We are reinforcing the idea, but we saw before this.
Yes.
Okay, now let's go move on to number 8. Number 8 is given this famous triangle. Number 8 is the theta. This is the hypotenuse, is 10, and the opposite is 7, no? And they want to know cosine. Cosine theta. So now you have two sides. You need immediately find the third side. It's a square root. The hypotenuse square is 100. That thing is square. Minus 7 square is 49. Subtraction of 51. Square root 51. This is this side. The length of this side. Now, by definition, I know that cosine is the ratio between adjacent over hypotenuse. Adjacent is radical 51 and hypotenuse is 10. End of story. This is the answer. This is the option A, no? You see? Option A. Any question? Clear?
So, Professor, sorry, I do have a question.
Mm-hmm. No.
So, Professor, we want to find the other side, right, Professor? That is why we use that.
Always. So it's given 2, and you need to find this, the third one using Pythagoras theorem. And remember, when you have a hypotenuse addition, when you have a lead subtraction.
Okay, sounds good. Thank you.
Yeah. Okay, now let's try to bring the next page. Okay, do you want a copy? Or you are familiar with the package we are working, no? I copied the figure here.
Yes, I am.
Yeah.
Thank you, Professor.
Yeah. So this, the next one I have in my paper here in front of me, a triangle like that, in which this side 3, this side 10, this is a right angle of course, this is a right angle of course, and this is my famous theta. I need to compute tangent theta. Tangent by definition is the ratio between opposite and adjacent. Okay, this is the opposite 3 and adjacent is 10. End the story. Wow, easy.
Very easy.
Option D. Now this is easy. This test is easy. The second no, but the first is super easy. Number 10. Number 10 is this different, no triangle is given. Is given sine theta is 2 radical 2 divided by 3 semicolon cosine theta is equal 1/3, and they want to know tangent. There are two different ways to do that. One way is do the triangle. So people prefer do the triangle. I know by definition this guy is opposite. This guy is a hypotenuse. This guy I suppose is adjacent. And this is hypotenuse. They are perfect coincidences. Hypotenuse is 3. Opposite is 2 radical 2. And adjacent is 1. And this is my famous theta angle. Therefore, tangent by definition is opposite over adjacent. Opposite is 2 radical 2 divided by 1. The answer is 2 radical 2. And that's it. It's the option B in the package. This is one possibility. Another students do the triangle, okay? And we use identity. What kind of identity? Tangent identity. Tangent by identity is division sine divided by cosine. Remember again our cheat sheet of the trigonometry, we have the collection of the most important identity. So far we studied not too much, but in the second chapter, wow, we studied a lot of identity. That's a division. Division 2 radical 2 over 3 divided by 1/3. It's easy. This 3 is cancelled. Oh no! Another way is 2 radical 2 divided by 3 times 3 over 1. Because in division you flip it that fraction. This 3 is cancelled out, the answer is 2 radical 2. Either way, guys. Using identity or using triangle. 11 is similar. Sine theta is equal to 1 over 4. And cosine theta is radical 15 over 4. What way you prefer? Identity or triangle?
Identity, because it has a formula.
Exactly. Entonces, pero in this case, they want to find cotangent. Entonces, you're using the identity for the cotangent, que es the reciprocal, es cosine in the top and sine in the bottom. And just division. Cosine is radical 15 over 4 divided by 1 over 4. And one shortcut to make this is you cancel out that 4, and the answer is radical 15. End the story. Option A. Super clear or super confusing?
It's clear.
May I erase the board?
Yeah.
Yes.
Okay, super. 12. 12 is, well, 12 is easy. Wow. Cosine pi over 4. Guys, we can use everything. We can use in unit circle. You can use in the table that I sent to you in the PowerPoint, or you can use a calculator. Well, there are calculators que es no possible doing that way, but some calculator, yes. O sea, I know que Juan, cosine pi over 4 is, sorry, cotangent. Es, a ver si, cotangent, COT. Cotangent. This is T. Because maybe you are not clear about cotangent, but I know que es reciprocal tangent, y I know que tangent pi over 4 is 1, 1 over 1 is 1. So basically, tangent pi over 4 and cotangent pi over 4 is the same, it's 1. Cotangent 45. Well, suppose I have no idea. Totally lost. 1 over tangent 45. Pero es cotangent, ¿no? Cotangent 13 es cotangent 45. Yeah. Es tangent 45. Es reciprocal. Cotangent 45. Cotangent pi over 4, cotangent 45. It's the same stupid thing, right? Es 1, ¿no? Es 1, que es de opción C. Es 1. Wow. It's given in degree and radian. Es 1. Cotangent, no cosine. Cotangent. Okay, 14. 14 is cosine 30 degrees. Oh, it's easy. I know by memory que es radical 3 over 2. Actually, you memorize this or not?
Yes, Professor. Just the 30, 60, and 45.
Yeah. It's the only thing. 30, 45, and 60. The rest is using memory device. 15. 15 is secant. Secant is weird. Pero I know que secant es reciprocal of cosine. Y I know que cosine 60 degrees 1/2. And reciprocal 1/2 is 2. Get the option D. So I never in my life memorize secant, cosecant, and cotangent. I using the identity. I memorize only sine, cosine, and tangent maybe, yes. Si you don't know, you divide sine divided by cosine, and cotangent is cosine divided by sine. 16 is cosecant. Cosecant pi over 6. Well, I have an idea, but I know that the reciprocal sine. Pi over 6 is 30 degrees. And sine 30 degrees is 1/2. Therefore, the answer is 2. Okay, the option A. Okay, 17. Everyone follow me, guys?
Yes, Professor. Professor, can I? Okay, you are not erasing, so okay.
No. You want to make it soon? $17. 17 is cosine pi over 3. So you are not familiar with the radian. You convert to degree, it's 60 degrees. It's 1/2.
We can do that on the test too, Professor. It's not a problem.
Say again?
If we can do on the test, we can convert to degree on the test.
Either way que you consider it better, I understand. Every right way for me is good. Some people, no, never. I don't like radian, okay? In calculus, you have to work with the radian. Okay, let's go now to 18 to 25. Okay, find reference angle. This is a little bit more complicated. Okay, may I erase the board?
Yes, Professor, you can. Thank you.
Okay. 18, reference angle. Let me refresh your memory. Well, let's do it one by one. Okay, 18 is angle 62. So theta is 62. I need to find alpha. Alpha is the reference angle. A reference angle, let me refresh your memory, is my friend can help me to understand the given angle, because maybe sometimes no, in this case super straightforward, but in the case no. Entonces now is the reference angle que always lie in the first quadrant, and the trigonometric function of the theta and alpha is the same value, not exactly the same sign. You adjust the sign according to the quadrant. But in this case, it's obvious. You first of all identification in what quadrant lie theta. No, theta is obvious que lie in the first quadrant. Therefore, alpha and theta is the same. Boom. That's it. Do you understand? Okay, now theta equal 122. Ooh, I need to find alpha. I have no idea. So now you identification en what quadrant like 122, que es obvio que es el second quadrant.
1 second.
Exactly. Second quadrant. Ok, entonces the reference angle, what is the formula? Bueno, we have formula, pero si you don't like formulas, it's only is the angle formed by the terminal side and the x-axis. This guy. And this guy is 180 minus 122. Que es 58. Okay? You want the formula? Okay. The formula in the second quadrant is 180 minus theta. Es the formula for finding alpha. Que es the reference angle. Good or not good?
It's good. Thank you.
20. 20 is confusing. No, this is no too easy. Theta is equal to 379 degrees. Boom. Boom. Entonces, this angle, I immediately see gets bigger than 360. Entonces, one revolution. One more than one revolution. But how much more? You're subtracting 379 minus 360. That's one revolution. And give me 19. Entonces, the interpretation, this angle is one revolution, 360, plus something more, que es 19 degrees. Actually, 379 degrees lie in the first quadrant. But alpha is not equal theta, is equal 19 degrees. Okay, in this case, it's similar to the 18 but of course you're using coterminal angle, coterminal. So you're subtracting 360 or either way. You follow me?
Yes, Professor.
21. 21 is is negative, theta is equal negative 361. Immediately you see negative angle. It's because the angle rotate, pero clockwise. Not in the conventional direction, it's counterclockwise, it's clockwise. It's like that. 360 is this. But you know, stop. And 360 is 1 degree more. This is the picture que represent our angle. Entonces es obvio que this is equivalent theta negative 1 degree. Yes or no? Because you, in this case, you go backward. You adding 360. Que es 1 revolution. Es negative 1. Pero negative 1 lie in the fourth quadrant, no? Okay. In the fourth quadrant, there are two different ways to express it, the angle. Or using clockwise, que es easier, using negative, or counterclockwise, que actually would be 359 no? Degree. Pero no, it's okay. The most important is que alpha is equal to 1 degree, because that is the angle. The angle formed by the terminal side and the x-axis. This is alpha. End the story.
Professor, I have a question.
Go ahead.
The alpha needs always to be positive because
Always. Alpha is always positive. Alpha is one angle que lie in the first quadrant. It doesn't matter the quadrant que lie, the original angle, you find the reference, que es my friend, to understand, que have exactly the same value of the trigonometric function, but lie in the first quadrant. And just adjust the sign of the trigonometric function, no? Okay, they want. Clear?
yes.
22. 22 is minus 42 degrees. Okay, theta, again, is negative 42 degrees. Ooh, in what quadrant lie this guy? Well, it's negative, entonces es clockwise rotation. 42, I suppose que here. Negative 42 degrees. Therefore, lie in the fourth quadrant again. In the fourth quadrant, when it's negative, entonces alpha is equal to positive 42. That's it. This is alpha. The same value, but positive. Always positive. Any trigonometric function you need to find in negative 42 a similar value of the 42, but you adjust the sign.
Professor, can I ask another question? So, Professor, when we have like an angle that is already on the first quadrant, we need the alpha is the same value, but positive, right?
Absolutely. Remember, in the first quadrant, all trigonometric functions are positive. Entonces, you compute the value. Suppose que the value you put in the calculator is 0.585 of the reference angle. It's positive because lie in the first quadrant. However, you adjust the sign. Oh, suppose que you compute tangent something, and in the fourth quadrant is negative. So you change the sign. But I promise you see example now. So basically, in this example, we only practice find the reference angle, find the reference angle, find the reference angle, find the reference. That's it. Repetition in different cases. 23 is negative. Theta is negative 253. Again, negative angle. Don't be scared with the negative angle. So people say, I hit the negative angle. No, it's the same stupid thing, right? But you rotate clockwise, no? Entonces, en what quadrant like this? Bueno, okay. I know que rotate in this direction. Dice negative 180, pero continuo, ¿no? Ajá. Entonces, suppose que negative 253 lie in the second quadrant. Do you see or no?
Yes, Professor.
Now, in order to find that angle, suppose I want to find that angle. Because for me, it's easier to understand this. One of these is 360 minus 253 is 107 degree. And this is alpha. No, remember alpha is, let me use alpha, another color, is this angle. Que is 180 minus 107 is 73 degree. Okay? And this is the guide using to find the trigonometric function. You adjust the sign. But I know that my original angle lie in the second quadrant. But this is my reference angle that always lie in the first quadrant. But any trigonometric function of the 73 and the 253 negative coincidente perfectly in the value, not in the sign. 24. 24 is theta is equal negative. Wow. I like the negative when they did this package. Wow. Okay, this is you subtracting 360. Because it's, it's again clockwise. This is 360. So now, so you're subtracting this number. Actually, it's plus 360, no? Because you are doing backward. Is negative 157. Negative 157, we continue here, but stop in the third quadrant. Makes sense, right? Okay, this piece is 360. One revolution. And this piece is 157 negative. Okay, of course, is more than 180 doesn't lie in the third quadrant. So I determine my angle lie in the third quadrant. Now I feel no, because negative is not good for me. So I find this angle, look, this angle, and counterclockwise to determine actually the value. This one. So this is 360 minus 157. In order to convert to positive, to see more clear, is 203. Makes sense because in the third quadrant, 203 is perfect. Now my alpha, let me use another color, blue, is the angle. And the angle is 203 minus 180. Now the formula in the third quadrant, guys, alpha is equal to theta minus 180. Is 23 degrees. And this is my reference angle. Okay, in this case was weird. We need to do several operations. First of all, it's negative. You add in 360 in order to go backward. And you get negative also, but you see que es only the coterminal, no? Negative 157. Immediately, I don't like negative angles. I convert to positive. So says 360 minus this. Now I discover que this angle, que actually is negative 157, is equivalent in positive notation, que is more clear for me, 203. Now in order to find the reference angle, que alpha, well, you apply the formula or find the acute angle que connecting the terminal side and the x-axis, is 23 degrees. It was clear or no? It's important, guys, you make a sketch to understand the angle, right? Go ahead. Question?
No, I said it is clear, Professor.
Okay. It's clear. 25. Well, 25 is the same stupid thing, but using radian. Theta is equal to 5 pi over 4. On a 5 pi over 4 line, I suppose in the third quadrant, no? Because this is pi over 4, it's a 3 pi over 4. Ow, in the middle, is set. 3 pi over 4. And this is 5 pi over 4. And by the way, this is 7 pi over 4, but I don't care. That angle is here, lie in the third quadrant. So now my reference angle is this. Actually, it's pi over 4, no? It's 5 pi over 4 minus pi, que is 4 pi over 4, is 5 minus 4 is pi, 1 pi over 4. This is alpha. Super. Option C. Important to analyze this, make a sketch. Determine in what quadrant lie the original given angle. And after that, you determine the reference angle, not necessarily formula. It's the angle between terminal side and x-axis. You only consider it positive because the idea can lie in the first quadrant. No? Entonces I complicate a little bit now. Okay, more interesting. Is using trigonometric function. Okay, but we're using the same idea of the reference angle. Suppose I need to compute a sine 495 degrees. Because I have no idea how many revolutions. Well, it's more than 360. So one more revolution. So you take 495 and subtract 360. When you subtract it, it's 135. Wow. So what is the interpretation of the famous angle? Well, it's one revolution. Two, and continue to the second quadrant, que is in 135, is exactly in the middle of the second quadrant. So our angle lies in the second quadrant. By the way, I know okay, sine in the second quadrant is positive. Remember the mnemonic UI, all students take calculus. That means in the first quadrant, all trigonometric functions are positive. The only guy gets positive in the second quadrant is sine, and his family gets cosecant. And the third quadrant tangent and cotangent, and the fourth quadrant cosine and secant. Okay, so you find the reference angle, because for me it's countable. This is the reference angle, alpha. Alpha is obvious que es 180 minus 135, que es 45 degrees. Therefore, sine 45 degrees. I know by memory que es radical 2, no? I was sine. Oh, it's positive, because I know that sine is positive in the second quadrant. End the story. Option B. Any question? Do you see the application of the reference angle?
Yes, Professor. So it's positive because it's on the second quadrant, right? Okay.
This is 90. 27. Wow, 27 is a little bit more complicated. It's tangent 750 degrees. Well, you can subtract the 360, 360, 360, 360, but sometimes it's too boring doing that way because you see the problem that we are doing in the lecture, this heavy number. So one possibility is instead of subtraction is division, because division is the same procedure of subtraction, but division is several subtraction in one step. So you divide 750, divided by 360, and the calculator, no? And you get the decimal, horrible decimal. That's 2.083 repeated. I don't care this. That means these two indicate it's 2 revolution. Because 360 is 1 revolution, 2 revolution is 720. And a little bit, one more. And one more you find, you delete the whole part, you take only the decimal part and multiplication again by 360. I did that. And the answer is 30 degrees. Wow. Interpretation of this. This is 1 revolution, 2 revolution, and continue 30 degrees. Therefore, my angle 750 lie in the first quadrant. In the first quadrant, all trigonometric function is positive, and this is equivalent tangent 30 degrees. And tangent 30 degrees, I know by memory or no, es radical 3 over 3, no? So you don't know by memory, no problem. Because I know sine and cosine, using the identity, tangent 30 degrees is equal sine 30 degrees divided by cosine 30 degrees. Sine 30 degrees 1/2 and cosine 30 degrees radical 3 over 2. You want to cancel out these two, it's 1 over radical 3, rationalize. Radical 3 is radical 3 over 3. Any question?
So, Professor, I do have a question. I memorized like the tangent for 30, 45, and 90. So we need to memorize the cosine, the sine and tangent, or just the sine and cosine?
Well, either way, actually, I memorize, my professor, memorize sine, cosine, and tangent. Some people say, no, too much. Entonces, memorize only the information in the unit circle. The unit circle is sine and cosine, because the first component is cosine. So in the unit circle, you see unit circle, bang. And one angle here, you have order pair. The first is cosine, comma sine. And some people memorize this number and this number in 30, 45, and 60. End the story. 1 and 0 and 90. The rest is using the identity to find tangent, cotangent, secant. What do you consider better for you, Nuera?
No,
I need to hear opinions.
I think I prefer, it's just me. I do prefer I memorize the sine, cosine, and tangent of 30, 45, and 90.
Me too. But some people, no. Remember, the people are different. The different kind of learn, visual, let's say, visual or voice, sound, sacotoa. I never see before this, but it's good. Sacotoa. Okay, 28 is cosecant 600 degrees. I need to investigate 600 degrees. Well, you divide by 360, or in this case, I don't know, I did different. I subtracting 360. There is 240. Oh, nice. And 240 lie in the third quadrant. So 600 degrees is 1 revolution. Continue, and stop in the third quadrant. This is my angle, the representation of the original theta angle. What is the reference angle? The reference angle is this angle. The reference angle is 240 minus 180 is 60. I know que cosecant 60 degrees, at least the value, the actual value, es igual a cosecant 600. Entonces es 1 over sine 60 reciprocal. Y I know that this is radical 3 over 2. Flip it to radical 3, rationalize es 2 radical 3 over 3. And this is a super important moment. The cosecant 600 degree que lie in the third quadrant, es obvio que the sine and cosecant are negative. Entonces the answer is negative 2 radical 3 over 3. It's the answer que I need. Clear or no?
Professor, but they are on the second, so it means they are positive, right?
Yeah. But in this case, a third quadrant. No? Look, this is important information. Third quadrant.
Oh. I got you.
600 lie in the third quadrant. I prove here. Subtracting 600 minus 360, que es 1 revolution, is 240. And 240 lie in the third quadrant. Okay?
I got you. Thank you, Professor.
You know, we have too many details in this problem, no? Cotangent 390 degrees. Okay, wow, I am lost. Well, no, I am not lost. You subtracting 360, no? It's 30. Okay, this is the interpretation that angle is 1 revolution and 30. This is theta. And alpha is this guy. Alpha is 30 degree. Entonces cotangent 30 degree is radical 3 because of the reciprocal. I know que tangent 30 degree for a student can memorize is radical 3 over 3. Reciprocal, this is 3 radical 3. Radical 3 radical 3 rationalize is 3 radical 3 over 3. And the 3 is cancelled and stay only radical 3. And what about the sign? Is the same or different? Is the same? Is positive or is negative?
It's negative, Professor.
Oh, it's positive. Because 390 degree lie in the first quadrant.
Is the 4. Sorry, Professor. It's in the
Okay, 390 degree lie in the first quadrant. Okay? Therefore, alpha and theta is the same. Okay? This is 29, no? 29.
The thing that made me confused is like, we need
this is the moment to clarify everything.
Okay. So the thing that made me confused is we need to we need to subtract first for example for 360, right, Professor? This is the angle that we're gonna.
When you subtract 360, the action that you are doing is remove 1 revolution. Remove. The 390 minus 360 is you remove 1 revolution because my original angle rotate 1 entire revolution plus something. And something is 30 degree. And 30 degree lie in the first quadrant. Make sense?
Okay, I got it. So we're gonna remove 1 revolution in order to have the angle that we're gonna work.
You remove 1 revolution, 2 revolution, 3 revolution, or divide. Because sometimes the subtraction is too long. Entonces now my goal is determine after you rotate 1 revolution, 2 revolution, any revolution, you stop in 1 quadrant. 1 quadrant you stop, first quadrant. Entonces actually 390 degree is coterminal angle with the 30 degree. Therefore, any trigonometric function of the 390 degree is positive. Because 390 degree lie in the first quadrant. It's 29, 30, no? 30. 30 is 30. All right, 30, 29, 29. Okay. 30, okay, good. 30 is compute sine negative 2 pi over 3. Entonces, negative sign, I don't know. No, you know very well. Don't be scared with the negative angle because we're using the property of the even odd. Y I need to know que sine is odd function. Entonces, negative sine 2 pi over 3. Ajá, entonces 2 pi over 3, bueno, you don't know. 2 pi over 3 lie in the second quadrant, no? 2 pi over 3 is here. Okay, 2 pi over 3 is equivalent 120 degrees, no? This is theta. And alpha is this guy. Que es pi over 3. This is pi minus 2 pi over 3. This is 3 pi over 3, using the same denominator, 2 pi over 3. And 3 minus 2 is 1 pi over 3. So alpha is pi over 3, que es 60 degrees. Entonces es equivalent to say sine 60 degrees, que es radical 3 over 2, ¿no? But don't forget the negative in the front. Entonces actually the answer is negative radical 3 over 2. Okay, you ignore the negative. The negative you put outside. En sine, en tangent. En cosine, no. En cosine is even function and the negative disappear, delete. Everyone follow me?
Yes, Professor.
Okay.
Yes, Professor.
Professor.
Tangent. Go ahead.
Sorry, Professor. I'm just wondering if you have like the time to explain like the graphs again.
Well, I suppose we have no time.
Maybe I'll go to tutoring, like today or tomorrow.
Okay. Pero es easy, Nuela, es 5 point. 5 point. Pero bueno, okay. Let's do an example again. We cover everything. Okay. Tangent 7 pi over 6. Bueno, tangent 7 pi over 6 lie where? Lie. You have in the cheat sheet that I provide you the first day, you have the unit circle. And so you don't waste the time. You little by little be familiar with this. You see, wow. I know my memory, of course. It's in the third quadrant like that. Boom. This is theta equal 7 pi over 6. Okay, by the way, in degree is 210 degrees. This is theta. And who is alpha? Well, alpha is this guy. I don't put the direction, doesn't matter. This is alpha. Alpha is 30 degrees. Because it's, you know, si you are doing mathematically, it's 7 pi over 6 minus pi, que es 6 pi over 6. Que es pi over 6. Entonces, you compute a tangent, pi over 6, like the angle in the first quadrant, que es radical 3 over 3. And what about the sign? Is negative or positive of the original? Is negative or positive? I know that the value is radical 3.
It's positive.
It's positive because the tangent is positive in the third quadrant. Very well. Plus. You emphasize plus. Guy? I'm doing too fast or no?
No.
No. Okay, 32. Another kind of question. Interesting. Very, very interesting. Is one trigonometric function is given 209. Tangent say que es negative less than 0. And indirectly give me information in what quadrant. So I propose you do this sketch. Look, I know, using my eyes, que cosine is positive. Que cosine is positive here. Oh no, it's here and here, right? That sign is positive. In the first quadrant, all trigonometric function is positive. However, tangent is negative in the second quadrant and in the fourth quadrant. The coincidence in between two conditions, bam, this and this together is 4 quadrant. Actually, looking this, you determine that our angle lie in the 4 quadrant. Do you understand this or no?
No.
No. Okay, I see, Noela, que cosine is 2/9 positive. Y I know que cosine is positive in the first quadrant y in the fourth quadrant, correct?
Correct.
Other hands, tangent is negative, less than 0. And tangent is negative in the second quadrant and the fourth quadrant. Two conditions together, because this comma represent like an is intersecting in the fourth quadrant. And you indirectly determine that the angle theta is located in the fourth quadrant, correct?
Correct.
Now I'm doing my famous triangle. No good. Okay, this is theta. And cosine by definition is adjacent over hypotenuse. And you determine the third side, que is square root. This guy square is 81 minus this guy square 4. So this is 77. And they want to know, in this example, they want to know sine. Okay, the answer is, or the question say, compute sine theta. And sine theta by definition is opposite over adjacent. It's radical 77, is the opposite, divided by hypotenuse, que es 9. Okay, pero this is negative or positive. This is the challenge. Determine if it's positive or negative. Oh, I come back at the beginning. I know that my angle lie in the fourth quadrant. Yeah, I know that sine, any sine in the fourth quadrant is negative. The answer is negative. Good or not good? Okay, this is a little bit different problem in which using the signs of the trigonometry function, you investigate in what quadrant lie. You are doing the famous triangle, you determine the third side, and you compute numerically the sign, this angle, but you adjust the sign according to the quadrant line. Suppose 33 say, secant theta is equal to 5/2. And theta lie in the fourth quadrant. Wow, I appreciate so much this information. Fourth quadrant, okay. And Roman number, fourth quadrant. I want to compute tangent. Okay. Si es tangent, I know that my final answer would be negative, no? Because tangent in the fourth quadrant. Okay, entonces now I have no idea. I am confused with the secant. I never memorized secant, but I memorized cosine. Cosine is 2/5. I flip it that. My famous triangle look like that. This is theta. Wow, nice, 90 degrees. This is adjacent, or this is hypotenuse, and this is square root 25, 5 squared 25, minus 2 squared is 4, this is 21. Okay, entonces now the tangent definition is opposite, que es radical 21, divided by adjacent, que es 2. And this is the crucial moment to adjust the sign. Is positive or negative?
It's negative.
It's negative. Because my angle lie in the fourth quadrant. Okay, 34. 34 say sine theta equal negative 2/5. And comma, tangent theta is positive. Wow, I need to discover in what quadrant lie theta. Well, sine is negative here and here. And tangent is positive here and here. Therefore, the coincident two condition is third quadrant. Okay. The sine is negative. Tangent is positive. Third quadrant. Third quadrant. Third quadrant. Third quadrant. Third quadrant. Okay. Now I do my famous triangle. In the triangle, neither I put negative value. No. You forgot that negative, temporary. And you put 2 here, get the opposite, and hypotenuse 5. And you find the third side gets 25 minus 4. Again, 21. Okay, nice. Okay, entonces I need to find what trigonometric function I need to find in this problem? Secant. Goish. Secant theta. Secant, but I don't remember secant. I remember the cosine. Okay, entonces cosine is the ratio between adjacent, que es radical 21, divided by hypotenuse, que es 5. Flip it up. 5 over radical 21. Rationalize. Radical 21 is 5 radical 21 divided by 21. And the answer is positive or is negative?
It's negative.
And negative. You need to find secant, no? Secant. Wait. Secant. Yes. Entonces it's negative. The answer is negative. So you determine the value, nice. But you adjust the sign. Then you put it here, secant theta, repetition again, is minus 5 radical 21 divided by 21. Okay?
Professor, can you zoom out for a second?
Yeah, of course.
Thank you.
It's okay?
Okay, Professor, can I ask you a question? So when we have, like, for example, they give us that information that tangent is less than 0, is where we need to find if it's like in the first, second, third, or fourth quadrant?
Claro.
Okay.
Of course, absolutely. Mister, it's okay? The Zoom?
Yes, sorry.
May I erase the board?
Yes, Professor.
Okay, let's do it. Erase the board. Okay, let's move on to the question 35, no? 35. 35 is cosecant is given is negative 9.4, comma. It's nice. This is explicit clear que theta lie in the third quadrant. Okay, super. I appreciate so much your help. Now I need to find what? I need to find cotangent. This is the information I need, cotangent. Okay, let's do it in the famous triangle. Always taking the segment positive, never negative. 90 degree here. This is my famous theta, and this position always. And this is, well, this is cosecant, but I am not familiar with the cosecant. I know that sine theta is equal negative 4 over 9. So it's obvious que the opposite is 4 and the hypotenuse is 9. And this is square root 81, que es 9 squared, minus 16, que es 4 squared. And the answer is 65, square root 65. Okay, entonces our famous cotangent by definition is adjacent divided by opposite, que 4. Cotangent, I know very well que the third quadrant is positive. Not necessarily you put the positive, guys. Si you omit the positive, default, you suppose que it's positive. Everyone follow me? Help me. Yes, no?
Yes, Professor, we are following you.
Okay. 36 is tangent theta given is negative 10 over 3. And theta lie in the second quadrant. Nice. Okay. Therefore, immediately I do my famous triangle. Always the same sketch. Chewy. 90 degree here. Okay, this is 10 and this is 3 because I know que tangent by definition is opposite over adjacent. The hypotenuse is square root. The sum of the square is 100 in square plus 3 square get 9. It is radical 109. And they want to know cosine. Cosine theta is the ratio between adjacent over hypotenuse. Rationalize is 3 radical 109 divided by 109. And what about the sign? Is positive or negative?
It's negative.
It's negative because I know that any cosine in the second quadrant is negative. Cosine for any angle que lie in the second quadrant is negative. Okay, 37 now. Cotangent theta is equal negative 9 over 2. And cosine, wow, is negative. Okay, I saw using my eyes que cotangent is negative. Well, cotangent is negative in the second quadrant and in the fourth quadrant. Because I know very well que cotangent and tangent are positive in the first quadrant as all trigonometric functions and in the third quadrant. All students take calculus, no? Okay, therefore cosine is negative here and here. So the coincidence is this. My fantastic conclusion, the angle that we are working in this example is lie in the second quadrant. It's a fantastic conclusion. And now I am doing my famous triangle. Nice, 90 degree here, this is theta, always the same sketch. And cotangent, I know the ratio between adjacent and opposite. And the hypotenuse is square root. This guy squared is 81 plus, when the hypotenuse you always plus, and the left is subtraction. 485, square root 85. And in this example, they want cosecant theta, pero I don't remember cosecant. I remember only que cosecant is reciprocal of sine. But I remember very well que sine is the opposite, que es 2, 1 over 2 over hypotenuse, que es radical 85. Flip it up, is radical 85 divided by 2. I come back to the problem of the sign. This guy is positive or is negative. We are talking about sign. So we compute the cosecant throughout the sign. In the second quadrant, I know very well that the sign and cosecant are
positive.
Exactly. End the story. Okay, the rest of the problem is straightforward, elementary kindergarten. Is look, 39, or 38, sorry, is sine negative 60 degree. Remember, the famous even odd function. Sine is odd, so minus sine 60. And sine 60 is radical 3 over 2, so the answer is minus radical 3 over 2. Good?
Good, Professor. If it was even, we wouldn't like eliminate the negative, right?
Look at this example, Noela. Cosine negative 30 degree, is equal cosine positive 30 degree. Okay, it's same value, radical 3 over 2, but opposite. I don't care. In the cosine and secant, I don't care the sign. So don't frustrate with the negative angle, because you apply that property, even odd. Odd is when the function you replace x for negative x is a negative in the front. And the even, when you replace x for negative x, nothing happens. And odd is sine and tangent. And even is cosine. And his family, no? Cosecant, cotangent, and secant. 40. Secant. Negative 30 degree. Wow, it's secant 30 degree positive. And just I don't remember, but I remember que recibe cosine. Yeah, I remember que cosine 30 degrees is radical 3 over 2. Flip it to radical 3, rationalize, radical 3, radical 3, radical 3, 2 radical 3 over 3. And of course positive, no? Because I delete automatically the signs. 41. Tangent, negative 30 degrees. Oh, tangent is odd function. Entonces minus. Entonces, the student can memorize the tangent 30 degree, que es radical 3 over 3, put negative radical 3 over 3, sorry. Okay. 42. 42 is sine negative 120 degree. Is negative sine 120 degree. Okay, 120 degrees, I don't know, because I only memorize 30, 45, and 60, but I find the reference angle. 120 degree lie in the second quadrant.
60.
Exo, bueno, 60. This is equivalent 60 degrees. So actually, I forgot 120. In my mind, I put sine 60. Okay, sine 60 is radical 3 over 2, no? But don't forget this negative here, right? There's a negative radical 3 over 2. Good?
Good.
43. 43 now. Sine negative pi over 4. Oh, es minus sine pi over 4. I know by memory que sine pi over 4, que 45 degrees, es radical 2 over 2. Es minus radical 2 over 2. Uf, easy, easy. Okay, well, entonces we have time to do at least one graph. What graph do you want? The graph que contain phase shift or no phase shift?
The one that contains phase shift.
For example, I select number 51. Okay, I consider important. Okay, graph it now, guys, by hand. Of course, you don't worry too much because you open decimals and the thing that we are doing roughly in a piece of paper, you verify in decimals, okay? Suppose, I repeat 51. 51 say y equal, do the graph of this trigonometric function, no? 3 sine, parenthesis, 3x minus pi. Okay, I saw clear like a water. A is 3, is the amplitude. So that means our sine oscillated, chin, like that, and between 3 and negative 3, no? This is the idea, the amplitude.
Yes.
The sine look like, sine and cosine look like the trajectory of the pendulum. The pendulum oscillate, boom, boom, boom. And suppose I move with the pendulum and do the graph in the piece of paper. It's oscillated. B is 3 also. And 3B I use it for the period. Period calculation is 2 pi over B, que es 3, es 2 pi over 3. And subinterval width, que es the famous 4 point or 5 point, we need to complete the period, is 2 pi over 3 over 4, no? Que es 2 pi over 12, que es pi over 6. Okay. This information enough is okay. I think no. The most important when you have phase shift, you take this expression and you set out one inequality always in between 0 and 2 pi. And you solving this using algebra. Plus pi, plus pi, plus pi. This is 0 plus pi is pi. 3x. This cancel out. This is 3 pi. Divided by 3, divided by 3, divided by 3. Therefore, my x travel from pi over 3 to pi. Because I know that the period is 2 pi over 3. However, my graph is so we make a partition of the x-axis. I don't care y-axis so far. My first point is obvious here in arbitrary position. I put pi over 3. How do you know that? Because this guy. U ending in pi. Is this guy. And we have 4 intermediate points. How you find that? When you adding pi over 3 plus pi over 6. Get the step. Each step is pi over 6, pi over 6, pi over 6. And you adding, calculator bajan either way. Entonces, the second guy is pi over 3 plus pi over 6 is pi over 2. Do you want I do the addition and the fraction in the board or no? It's okay or no? No.
Do we need just to add plus like pi over 6? That is our SIY. Okay.
The next guy is pi over 2 plus again pi over 6. Okay, is 2 pi over 3. 2 pi over 3 plus again pi over 6 is 5 pi over 6. And to verification, 5 pi over 6 plus pi over 2 is obvious because 6 pi over 6 is pi. And this is my period of the sign. No, okay, no problem, I understand. Now, I know that the amplitude is 3. So suppose que, well, the y-axis is here. I don't know exactly. It's here, approximately. Too far. Because it's pi over 6, pi over 6. Pi over 6 plus pi over 6 is pi over 3. This is the y-axis. This is not important. And this the amplitude is 3. 1, 2, 3. 1, 2, 3. Yeah, I know that we are doing the graph of the sign. Yeah, I know that the sign starts in 0 in the first point. Maximum positive, the magnitude is 3. 0 again, and the next guy is minus 3 here, and 0. And we complete one period, one cycle. You want to extend it, well, you can, but this is not important. One period. Clear?
Clear, Professor. Thank you. I understood today.
Super. Well, guy, good luck. You have to work. Anything I can help for you, let me know by email. Okay?
Okay, Professor. So tomorrow you